Hi, gang. I wanted to give you a little bit of help with the first homework in section 2.6. Some of these are a little tricky for folks. It says let P be a point on the graph of y equals x squared minus 9. I hope now you look at that and think, oh, that's the basic parabola shifted down 9 units. And we're supposed to express the distance from this point on the parabola to the origin, 0, 0, as a function of x. Okay, let me drag this window over here and take a look at a picture on the whiteboard back here. So they're saying here's the graph of y equals x squared minus 9, vertex at 0, negative 9. And xy is a point someplace on here, and we're supposed to express this, the distance from the origin to xy, as a function of x. Well, of course I'm going to use the distance formula. So let me kind of quickly say this. Distance from xy to 0, 0 will be x minus 0 quantity squared plus y minus 0 quantity squared. Take the square root of that, you get the distance. And this cleans up a little bit, or a lot, to that. But does that answer the question? They want a function, they want the distance expressed as a function of x. And I think I've got too many variables here. I've got x that can change and y that can change too as this moves along the graph. So to express this as a function of x, I'm going to have to use the fact that I'm on this parabola and that every point anywhere on that graph satisfies that equation. So let me substitute distance as a function of x is x squared plus the square of y. Y is always x squared minus 9. Okay? That now gets me distance expressed just in terms of x. Let me clean this up a little bit. If I square this out, I'm going to get x to the fourth minus 18x squared, so a total of minus 17x squared, and plus 81. My board's pretty bad, but there's a clean version of that function. And let me see if Math Excel will agree with me here, that this should be the square root of x raised to the fourth power and subtract 17x squared and add 81. Come on, baby. Yes. All right. So what if d? What is d if x is equal to 0? Well, I can plug in 0 here and see it's the square root of 81. The meaning of that in the picture is, if you let this point move to where x is 0, you're down here at the vertex, the distance to the origin will be 9. Okay, let's check that. Yeah. What if x is equal to 1? You know, so what would the distance be if instead I let x be equal to 1, and I had to get this distance to the origin? It looks like it might be actually a little bit less than 9, just wild guess. But of course I plug in 1 right in here and get 1 minus 17 plus 81 is, I believe that's 65. They say round to the nearest 2 decimal places. Okay, so here we have square root of 65 is about 8.06. 8.06. Yeah. Okay. Now here we go. For what positive value of x is the distance going to be smallest? In other words, minimize the distance. Okay. So here is the distance function. Don't know if you can quite see it there. Plugged into my y list. The graph of the distance function, not the parabola, but the distance function looks like that. And you can see there are a couple of minimums. So I'm going to run second calc minimum. I think I'm out of time on my video, but I'm going to run second calc minimum to find that point, or those 2 points there, in order to answer this question. And it says what positive value of x, it'll be the x coordinate that I give. Out of 2 decimal places. Have fun with these. See you later.